Today we are going to look at the practical part for random forest. So there is this link I've shared in the chat. So I'm resharing the link again. So for those who've just joined now, so this is the link for our dataset. So I've uploaded an Excel file. So you can use this GitHub link to get that data, but I'll show you how we import it. So what I'll do is I'll create a new file. So dtrf.ipynb, and this will be for my random forest and decision tree models. Okay. Then I'll change my view so that you can see my code better. Okay, so today we are going to discuss something on decision trees and random forests. Okay, so that's what we are going to do. And the first thing we are going to do, so I'll give you 2 minutes to maybe switch on your Jupyter notebooks, then we can do the code along together. So at 8:08, we start the coding part. And for the first part of the code, you already know what we are going to do. So the first part of the code is usually importation of libraries that we need for collecting data. So I think we can proceed. So the first thing we usually do is import libraries. Okay. And here we will have the pandas library. So we will have import pandas as PD. Then we can have the NumPy library. We can have matplotlib. So we'll have import matplotlib.pyplot as PLT. And lastly, we will have Seaborn. Then we are going to ignore all warnings. So we are going to have import warnings, then warnings.filter warnings ignore. So these are the basic importations we are going to make. So we've been doing this all along. So you can go ahead and copy this from your previous notebooks and then we can proceed. So 1 minute you do that, then we proceed. And another thing I'll be showing you in this course is from the past. So when I was starting to code, so there was no such thing as AI assistants that could help you code along. So when I'll be showing you these things, I'll be utilizing AI to show you how it can ease your work. So what you need to understand on your side is how do I grasp this concept and how can I replicate what he is doing? So that's your main goal. And my main goal on this side is to help you, show you what are the steps that are basically followed when you are handling data and when you are creating machine learning models. Okay, so you should be done on your side. So we will go on to the next part, which is importing data. So here I will have my df being equal to pd.read underscore Excel, because it is an Excel file. Then I'll paste in the GitHub link that I've shared. So let me reshare the link with you again. So as it is here, but before that, let me run this and confirm everything is okay from my side. And when running this code, you have to ensure your PC is connected to the internet, because we are downloading this file from online. So let me run the first cell first, then run this secondly. So let me share that link in the chat section and then we can proceed. Okay, so this code is taking time to run, but we can wait. So in the meantime, you can take your time and copy what I've done here. So these are the challenges you might face when working with Visual Studio Code. So at times it might take long for your code to run than normal. Okay, so yeah, there you go. We have our data set. So this is the link we are using to get our data from an online source. So that is from GitHub. So hope you have something on your end too. So we can proceed. So we can explain what we have here. So we have region, we have state, we have country, we have listing price, we have price per square foot, and we have the square foot for each property. Okay. So if we check something like, so if we check something like the summary of the data, so we can have df.describe. So this will be for the numeric columns. So for the numeric columns, you can see the listing price as a count of 1000, has a mean of 342,364, the standard deviation of 125,913. So you can use these things to actually explain some of the findings you need. So this is the summary statistics for the numeric columns. So I won't discuss this here, so you'll have to maybe go through it later on. Then, so just type in df.describe. Then we have the summary statistics. for categorical columns. So we'll have df.describe, then include objects. So we have include square brackets object. So we want to include categorical columns. So here for categorical columns, you can see we have region and the count is 1000. Also state count is 1000, county state is 1000. How many unique values do we have in region? So we have 10 unique regions. Then we have 50 unique states. We have 648 unique countries. So the topmost region is the East North Central region. Then the topmost state is New York, and the topmost country is Washington, D.C. And the frequency of the topmost here, you can see East North Central, we have 100 values. For New York, we have 55 values, and for Washington, we have 19. Okay, so that's what you have. So what I can do is I can create a sample plot for you to show you the topmost regions or the count plot for the unique regions. So what I'll do is I'll draw the count plot for region. So this is just one of them. So I'll have sns.set. So just to set my figure, then I'll have sns.countPlot. Then we will have a plot of our region. So I'll type in df, then I'll select the region. So if we run that, we get an error. So we will have to get the value counts first. So we will have df. So we will have counts being equal to df region.value counts. Then we will have to create our figure. So these won't work. So this is what we have. A minute as I customize it. Yeah. So this is the count plot. So we have df region dot value counts dot plot. Then we have kind bar. Fig size is 10 by 5. So you can reduce it if it seems bigger. Then I rotate the axis by 45 degrees so that we can see each region. So basically what you are seeing here is each region has a value count of 100. And this is our sample count plot. So when doing your analysis, you need to confirm that maybe each region is well represented and maybe each state is well represented in the data. And that should be the case in this data set. So yeah, let me share this code in the chat and then we can proceed. So, and before we get here, so another thing we forgot to check was the dataset info. So I'll add another code cell here and type in df.info. This is the most important part first. So you can see our data has 5 columns, not 5, but actually 6 columns. So we have the region, state, county, listing price, price per square foot, and the square feet. Okay. And here we have 3 numeric columns and we have 3 object columns. So it means we have 3 columns that are categorical and we have 3 columns that are numeric. So numeric with continuous data set. So when creating an ML model, so first of all, what do we need to do? So we need to define our features and our target variable. So in this case, so I'll add some markdown cell here. So ML problem. So I'm defining my machine learning problem. So this is a regression task, okay? And since this is a regression task, our target variable is the listing price. So we want to see what's the listing price for each region, state, county, and price per square foot and the square feet that we have. So actually what we can ignore here is the pricing per square feet, because the square feet will be enough for us, but we will try use both and see the results that this data will give us. So the problem type will be supervised. So we are fitting a supervised task. Then ML task is regression. So those are the things we are going to look at. So let's go down here and see what are the next steps that we need to follow. So the first thing we need to do here is we need to split the data into training and test set, but in this case I won't do that. So I will use the data as it is as a whole, but I can still go ahead and do that. So split data into training and test set. So that's what we are going to do here. And remember yesterday when I was taking you through the class, I showed you how we do the advantages of using decision trees and random forest. So that's the code we are using for splitting the data into training and test set. So what we do first is we import. So from sklearn.model selection, import train test split. Then we have our x being equal to df.drop. Then we drop the listing price column from the whole data set. Then axis should be equal to 1. Then our y should be equal to df. Then we select the listing price column. Then we follow the inbuilt method for splitting the data into training and test set. So as you are copying the code that is there in the chat section onto your side, let's go back to our notes yesterday. So I'll open my Notion notes and then I'll show you one thing that I explained yesterday, one advantage that I had shown you yesterday of using decision trees and random forest. So if I open the notes for decision trees, you can see here in the advantages part, it requires little data preprocessing, e.g., no need for feature scaling or normalization. So we don't need to normalize our data. Then another thing is can handle both categorical and numeric features. So it means that for this data that we have here, we don't have to convert these columns that are categorical here, which are objects, to be numerical. So we will fit our model with this data as it is and confirm if that's the case. So I can give you an additional 1 minute to copy this code for splitting the data into training and test set. Okay, so I think you should be done by now. Let me save this, then we can proceed. So the next step will be to import decision tree, regressor, and random forest regressor. So these two models come from different sklearn paths. So we will have this. So from sklearn.tree, import decision tree regressor. And an advantage of using decision tree is if we go back to the notes, you can see there is a code part where you can actually visualize your decision tree. So we will try copy this and see if we can visualize our tree. So let's go back to our code part. So we have that. So after importing decision tree regressor, what's next? So we instantiate the model. So we can have our D tree being equal to decision tree regressor. Then after that, we feed the model and we feed the model to the training data. So we will have our D tree dot fit, then X train, then Y train. So as you can see here, the steps that we are following here and down here are same to what we did in past classes. So if we go back to the part where we learned the ridge and lasso regression models, so this was the first few sessions we had. So you can see here for the creation of the dependent and independent variable, we had this step. And that step is here. The only thing that we've added is the splitting of the data into training and test set. Another thing is here. For the instantiation of the model, we are following the same steps that we have here. So we import the library, we instantiate the model, then we feed the model. So in this other side, we are fitting the model to the training set. Then what we do next is we predict. And here on this other side, we are predicting on the test set. So here you can see we are using XTrain. But for prediction here, so I can say ypred. You can see we have d3.predict. We predict on the X test. So that's just the difference between this class and the class that we had in the introductory part. So here we never split the data into training and test set, but here we've done that. So I'll save that and we will wait for our model to fit. Okay, so as that is running, we can check this part. So since we are not doing a classification task, okay, so I never ran this upper cell, so I'll have to run it. So let me copy the column name as it is. Then we can proceed. So here we have the listing price. Okay, so we have an error here. So listing price is not found in our data. So what I'll do is I'll run df.columns. Then here I'll select the listing price column as it is. So listing price column has an additional space here at the beginning. So you need to confirm that you add that additional space too on your side. Then I can run that. So the code has no errors as of now. So you can change this and confirm if everything is working. So you can take 1 minute and confirm that the splitting code is working on your side also. Okay, so we can proceed. So you should be done by now. Then we can feed the model. Then here we see could not convert string to float. So as we've mentioned in our data, so this advantage is false. So we need to convert our categorical columns to be numeric. So what should we do here? So what I'll do is I'll add another code cell here. And the code cell here, what I'll use it for is I'll use it to ordinal encode categorical variables. Okay. So we will have from sklearn.preprocessing import ordinal encoder. And when we were handling the encoding class, I showed you how ordinal encoder works. Then we will instantiate the object. So we will have our encoder being equal to ordinal encoder. So what we can do is we can check our X train. So we can check xtrain.head and see what we have. So we have 3 columns that need encoding. Okay, so let's do that. Then we go ahead and fit and transform the training dataset. So we'll have our xtrain being equal to encoder dot fit transform xtrain. But remember here we have only 3 columns that are objects. Okay, so what we will do is we will select the object columns. Okay, so I'll have this as the object calls, and what I'll do is I'll type in df dot select data types. Then we include objects. Then we select the columns and convert them to a list. So let's run this code up here first and confirm if it works. So yeah, we have those 3 columns as a list. Then here, when it comes to the encoding part, what I'll do is I'll take my xtrain, then I'll index the object columns, then I'll run the encoder.fit transform, then I'll run it on the object columns alone. Then what I'll do is I'll transform the test dataset also, and then we will have our data which is encoded. So let me share this code with you in the chat section and then give you like 5 minutes, and you can ask questions if you have any concerning what we are looking at the moment before we proceed. So just in case you don't understand what I'm doing, just in case you have a better way of doing this, you can share your suggestions. So 5 minutes, maybe at 8:38 we can proceed. So copy this, run it and confirm it's working on your side. Okay, so we have a value error here. Found unknown categories while transforming. Okay, so it means I'll have to customize this code a little bit more. So what I'll do is I'll move this code for encoding from being down here to being up here just before creation of the data split. So what I'll do here is after I've selected my DF, I'll take my DF and I'll fit transform the whole data. So don't worry, I'm sharing this whole code with you again, and I'll explain what I've done in a few. Then I'll have to move this again. I'll have to move it up here. So those are our columns. These are the categorical columns. And then this is the data encoding part. and then we go ahead and split that data into training and test set. Okay, so let me share this updated code with you in the chat section, then I can explain the changes that I've done. So what I've done here is when we ran our model, we got an error, and the error mentioned that we have this value error, could not convert string to float. Then the string was east, north, central. And east, north, central was part of the region column. And the regional column, we know it's categorical, okay? So what this means is we need to convert this value from being categorical to be numeric. So what I did is I came up here, then I did ordinal encoding before we could split the data into features and target variable, and before we could split the data into training and test set. So run that on your side and see if your model will work. So on my side, it's working. So yeah, I'll give you an additional 5 minutes to do that also on your side. So it's just changing this upper part here and including these two codes. And if you have questions, you can raise your hand or you can unmute and then we can try discuss. Okay, so I think we can proceed. So I went ahead and run the code to fit my ML model. So after running this, so what's the most important thing for a decision tree? So it's visualizing the decision tree itself. So if we go back to the notes, there is this code that we can use to visualize the decision tree. So I'll copy that and I'll paste it here in my code cell, and then we can go ahead and customize some few things. So first of all, we create our figure using object-oriented plotting. So we create our figure and axis. Then here we will have a subplot with a figure size of 12 by 12. Then what we do here is we specify our model. So we will have our dtree dot plot underscore tree. Then feature names should be equal to names. And for feature names, I'll just say df. Then I select only the columns that we have here. Or instead of that, I can pick these code that we have here. So df dot columns. Then we select only the first few columns and ignore the last column. Then class names. So we will have dtree dot classes underscore. Then field should be equal to true. Then we are plotting these on our axis. So let's give it a first run and see what we get. Yeah, so it's not working. So let's go back to our notes and see what we did. Okay, so this should be tree and not dtree. Is there another importation that was made? So definitely. So we should have this from sklearn import tree. Yeah, then we can be able to visualize our tree. Then it's saying decision tree regressor has no object classes. So I think this should be tree.classes. Let's confirm it from the code. So it's dtree.classes. Okay. So I know the reason as to why we can't plot our decision tree. This is because this is a regression model. So if it were a classification task, then we could go ahead and visualize our tree. But we can try. So we have plt.figure, fig size 20 by 10, then tree, plot underscore tree, then we have dtree, field being equal to true. Then we also try plt.show. So this is just a random try to see if we can get a plot of our tree. So after this, I'll want maybe one of you to share the steps that we can follow to fit a random forest regressor model. So yeah, this is our tree. You can see how our tree looks like. So definitely if we want to see all the details, you will have to extract this image in a more high quality standard. So here you can see the different decisions that are being made to come up with the price. But you would need to extract a high quality image to see the different outputs that we have here. But chances are we have a lot of outputs that are in here that you yourself can't explain. So these are the different routes that we can take when making a decision as to the predictions that we are going to make. So the other thing we can check is our model score. So we can type in d3.score, then we score on the X test and Y test. So the model is 94% accurate. And if we use the train data, X train, then Y train. You can see the model is 100% accurate. So the model is overfitting on the training data set, but giving us a lower score on the test set. So data that it hasn't seen yet, but on data that it has seen, the accuracy is 100%. So that's why you always come up with a test and training set to ensure that your model is not overfitting by much. So here it's overfitting by 6%. So anyone with a question, let me share the code for tree plots, and then you can include that on your side also. But I'll also share my notebook after the class. Anyone with a question? Okay, so if you have no questions, I guess we will finalize by looking at a random forest model. So for random forest, we will have import random forest regressor. Then for that, we will have from sklearn.ensemble import random forest regressor. Then we instantiate the model. So we will have our RF standing for random forest being equal to random forest regressor. After that, we feed the model to the training data. So we will have rf.feed xtrain ytrain. Then after that, we make predictions. So we will have our ypred being equal to rf.predict xtest. Then what I'm going to do is I'm going to print the model score. So we are going to have rf.score xtest ytest. Then we are going to do the same for training set. So instead of D3, we are going to have rf.score xtrain ytrain. So you can see the more advanced models we use, the better the results we get. So decision tree was overfitting by much. So here we had an accuracy of 194%. But you can see for random forest, we have an improvement. So it's 99% accurate when it comes to the training data and 97% accurate when it comes to the test data. So this is a difference of 0.2%, which is not that much as compared to what we had here, 0.6% accuracy. And if we go back to our notes, so when we were looking at the notes yesterday, we said that the advantage of using random forest is it is less prone to overfitting compared to individual decision trees. And from the example that I've shown you here, you can see the proof. So the training and test accuracy are really close to each other, which means that this model is performing both good on the training and the test dataset. So that will be all for today's session. So I'll see you guys again. I think it should be next week on Monday, where we will be covering even advanced ML models. So this will be more advanced as compared to random forest and decision tree. So this will be the XGBoost and the AdaBoost models, which we will discuss in detail. And then after that, we will discuss some of the other advanced concepts in machine learning, such as hyperparameter tuning. So how do you improve this score? So once you've attained 97% accuracy, so can you improve this score to be even more than 97%? Is there a chance to do that? So we will have a look at that also. Yeah, so that's all from me today.